Oxidation number is the apparent charge that an atom of an element has in a compound molecule or ion. The oxidation number helps in determining whether oxidation or reduction has taken place. It also helps in understanding the naming of inorganic compounds. Like when you see carbon, a CO2 being called carbon 4 oxide and CO as carbon 2 oxide. It is the oxidation number of carbon that gives the name either carbon 2 or carbon 4. When you hear the IUPAC name of sulfuric acid called sulfuric 6 acid, it is the oxidation number of sulfur in that acid, which is 6, that gives the name sulfuric 6 acid. What are some of the rules that are used in determining oxidation number? The first rule: oxidation number of uncombined elements is 0. E.g., if you have copper, that is uncombined, 0. Magnesium, oxidation number is 0. That of molecules is also 0. And we can have chlorine gas having oxidation number of 0, fluorine gas having oxidation number of 0. Second rule: the charge on the ion containing one element is equals to its oxidation number. Charge of the ion containing one element is equal to oxidation number of the element. E.g., if you have copper 2 ions, oxidation number is +2. If you have zinc ion, oxidation number is +2. If you have, for instance, chloride ion, fluoride ion, oxidation number is -1. The same applies to radicals, becomes the charge. For radicals, oxidation number becomes the charge. E.g., nitrate ion, oxidation number is -1, Ammonium ion oxidation number is +1. Carbonate oxidation number is -2. Rule number 3. The oxidation number of hydrogen is +1 except in metal hydrides where it is -1. So for example, in sodium hydride it is -1, but in water, which is not a hydride, it is +1. Oxidation and number of oxygen is -2 except in peroxides where it is -1. So if you have sodium hydroxide, the oxygen is -2, but in hydrogen peroxide, the oxidation number of oxygen is -1. In polyatomic ion, the sum of the oxidation numbers of oxygen constituent atoms is equals to the overall charge. So in radicals, the sum of oxidation numbers of constituent atoms is equals to the overall charge. For example, if we have a sulfate, e.g. in sulfate ion, the overall oxidation number is -2. So if you want to get maybe for sulfur, you equate to -2, and then that will give you the oxidation number of sulfur in that radical. Lastly, sum of oxidation number of constituent atoms of a compound is 0. That is, oxidation number of a compound is 0. For example, a compound calcium carbonate has an overall oxidation number of 0. And that is the summation of all of them. Let's look at some of the examples to determine the oxidation number of different atoms or elements. Examples: Work out oxidation numbers or number of nitrogen in the following compounds. A NO2. So that is N plus minus 2 times 2, and that is a compound equate to 0. That will give N minus 4 is equals to 0, and the oxidation number of nitrogen there is plus 4. Another example, you can have nitric 5 acid, that is N plus 1 for hydrogen plus minus 2 times 3, that is oxygen. Overall is 0, and that will give N plus 1 minus 6 equals to 0. N minus 5 is 0. N is plus 5. And because this is the oxidation number of nitrogen, the acid is given the name nitric 5 acid. Another one, you want to talk about nitrate ion, the oxidation number of nitrogen in nitrate ion. So that is nitrogen minus 2 times 3, overall charge is minus 1. So that is N minus 6 is equals to minus 1. N is minus 1 plus 6, therefore N is equals to 5. And this is the oxidation number of nitrogen in nitrate ion. So we have seen that it is the oxidation number of nitrogen in nitric acid that gives the name nitric 5 acid. It is the oxidation number of nitrogen in dinitrogen tetraoxide that brings out that name. Because we realize that when we talk about dinitrogen tetraoxide, then that is 2N plus minus 2 times 4 of them equals to 0. 2N minus 8 is equals to 0. 2N is 8, and N is therefore plus 4. So the oxidation number of nitrogen there is 4, hence the name dinitrogen tetraoxide. Another question, work out the oxidation state of carbon in oxidation state of carbon in a carbonate ion. So that is C plus minus 2 times 3. Overall charge is minus 2. That is C minus 6 is minus 2. C is equals to minus 2 plus 6, which is plus 4. And therefore, the oxidation number of a carbon in carbonate ion is plus 4. Let's see carbon in CO2. That is C plus minus 2 times 2, and that is a compound. So overall is 0. That gives C plus minus 2 times 2. That will give minus 4 is 0. C minus 4 is 0. C is equals to plus 4. Finally, I want us to conclude that is because of this that CO2 is given the name carbon 4 oxide. Let's look at oxidation number of manganese. Number 3, oxidation number of manganese in MnO4 minus KMnO4 and Mn2 plus. Let's start by the first one. In MnO4 minus, that will be Mn plus -2 times 4. Overall charge is -1. That is Mn minus 8 is equals to -1. Mn is equals to -1 plus 8. That gives plus 7. Hence the name manganate 7 ion. The second one, in potassium manganate 7, we have K, which is 1, plus Mn plus -2 of oxygen, and therefore equals to 0, because that is a compound. So that will give Mn plus 1 minus 8 equals to 0. Mn minus 7 is 0. Mn is equals to plus 7. Hence the name potassium manganate 7. The name 7 is from there. Finally, in the manganese 2, that is an iron, so the oxidation number is automatic, and that is plus 2. That is all about oxidation numbers and redox reactions. But remember, increase in oxidation number is oxidation, while decrease in oxidation number is reduction. And we are going to use that in the electrochemical cells.